Alright, so today we're going to use trig ratios in ways that we haven't done much of yet. So when we look at example 1, it says find A if measure of angle B is 85 degrees. So measure of angle B is 85. B is 9, and notice that little b is across from the angle B. So we'll put 9 here. Measure of angle A is 29 degrees. And we want to find A, that's our goal. Now when we look at this, we've solved problems like this before, either using Pythagorean theorem or trig ratios, but we've only been able to do that with right triangles. And if you look at this, this is not a right triangle. Okay, if I add these up, that does not equal 90, so this measure of angle C is not 90 degrees. So we got to think of another way to solve this. Now you've done problems like this before, we just haven't done much of them. So what I'm going to do is draw a little squiggly line, because we're going to solve this two different ways. The first way is how we've done it in the past. Now we know we can only use trigonometry with right angles, or right triangles. So I'm going to create two right triangles. I'm going to start from the vertex C and draw in a perpendicular line, or a line that is perpendicular to segment AB. Now I've created two right triangles. When you look at this then, I'm going to label this segment X, that altitude is X, and we're going to use X from both of these triangles in order to solve for A. So when I look at this triangle over here, I have the measure of angle B is 85 degrees. If I look opposite that, I have X, and the hypotenuse would be A. So opposite over hypotenuse would be sine. So I know that the sine of 85 degrees is equal to X over A. Well, if I solve this for X, I multiply both sides by A, I get A sine of 85 degrees is equal to X. If I look at this other triangle and I set up another trig ratio, I have the measure of angle A is 29 degrees. The opposite side is X. The hypotenuse would be 9. So I can say that sine of 29 degrees is equal to X over 9. Now to solve for X here, I multiply both sides by 9, and I get that 9 sine of 29 degrees is equal to X. So X is both equal to A sine of 85 degrees and 9 sine of 29 degrees. So I can set these two equal to each other and solve for A. So when I do that, I get that A sine of 85 degrees is equal to 9 sine of 29 degrees. Divide both sides by sine of 85 degrees. That divides to be 1, so I'm left with A is equal to 9 sine of 29 degrees divided by sine of 85 degrees, which is approximately 4.38. Now, this was a little bit longer than what we want to have happen all the time, so we want to come up with a formula that will work for triangles that are not right triangles, and that is called the law of sines. One of these formulas that we're going to use today is law of sines. So as we scooch down here, I'm going to derive a formula called law of sines. We're going to use that same picture that we did before. I'll draw in the altitude from the vertex C. I'm still going to label this X again. So here's your proof for the law of sines. You do not need to know this proof, but I wanted to show you how we get the law of sines instead of just telling you what the law of sines is. Well, if I set it up the exact same way as I did before, we have that the sine of B is equal to X divided by A. So if I multiply both sides by A sine of B is equal to X. I can also say that the sine of A is equal to X divided by B, opposite over hypotenuse. If I multiply both sides by B, I get B sine of A is equal to X. So notice that X is both equal to A sine B and B sine A. So I can now set these two equal to one another, and I would get that A sine of B is equal to B sine of A. If I divide both sides by A, that'll eliminate this a. If I divide both sides by b, I'll get rid of that b. So I'm really dividing by ab. Those divided by 1, b divided by b is 1. So we have sine of angle b divided by side length b is equal to sine of angle a divided by side length a. And we have this proportion, and we can use this now to solve the problem above. We could do something similar to prove angle C if we drew a different right triangle. I'm not going to do that here. If you want to, you can try that on your own. But this proves the law of sines, or sometimes it's called the sine rule. So the sine rule says, if triangle ABC has side lengths A, B, and C, as shown in the picture above, then the following is true. Sine of angle A divided by side length A is equal to sine of angle B divided by side length B, which is equal to sine of angle C divided by side length C. This is the law of sines, and we're going to find this very useful as we start trying to find angle measures and side lengths of triangles that are not right triangles, that we can't just use our regular trig ratios in order to solve. So let's go back to this original problem, example 1, and use the law of sines. Now when I look at this, I'm given measure of angle B and side length B. I want to find side length A, and I'm given measure of angle A. So if I use sine of measure of angle B over little b equals sine of measure of angle A over side length A, and substitute in, we're going to see that we'll get the exact same thing. So we have sine of 85 degrees divided by 9 is equal to sine of 29 degrees divided by A. We can solve this like we solve other proportions, multiply both sides by A and both sides by 9, and we will no longer have fractions. When we do that, we get A sine of 85 degrees is equal to 9 sine of 29 degrees. Solving for A, we just need to divide both sides by sine of 85 degrees. And we will get A is equal to 9 sine of 29 degrees divided by sine of 85 degrees, which, if you put this in your calculator, is approximately 4.38. So that is how we can use law of sines to solve the same problem. Go ahead right now and use law of sines to do the next example. It says use the information in the diagram to find how much closer to the nearest 100th mile Jimmy lives to the school than Adolf. So essentially what we need to find is both x and y, and it will allow us to see how much closer is Jimmy than Adolf, how much, what those miles are. So I got to find both x and y. So here I'm going to find x. In order to do that, opposite x is 17 degrees. I have this side length and the measure of the angle opposite it, so that's one ratio, and this will give me the other ratio. So sine of 17 degrees divided by x will be equal to sine of 102 degrees divided by 3. When I multiply both sides by 3x, I get 3 sine of 17 degrees is equal to x sine of 102 degrees, and I just have to divide by sine of 102 in order to solve for x. When I solve that, I get that x is approximately 0.896710 miles. I'm keeping all of these decimals right now, even though it says round to the nearest hundredth, because I don't want to round until the very end, so we want to make sure we do that. All right, so now I also need to find y. Well, if I look at y is opposite of an angle measure. I don't know. But I can find this out because we know the sum of the measures of the interior angles of a triangle add up to be 180. So I know that this angle measure is 61 degrees. So I want to find y. I need the angle opposite y. And I already have this angle measure and the side opposite that. So I can set up my proportion. Sine of 61 degrees divided by y is equal to sine of 102 degrees divided by 3. Again, when I multiply both sides by 3y, I will get that 3 sine of 61 degrees is equal to y sine of 102 degrees. And when I divide both sides by sine of 102, I get that y is approximately 2.682477 miles. Now, some of you guys may think, well, why not just use this proportion? Because I know what x is now, so I can use 17 degrees. You absolutely can do that. You can use these, this side length and this angle measure. However, I always like to use the values that the problem gives me in case I made a mistake somewhere, so that I don't use that mistake and continue it. So we know how far Jimmy lives from the school. We know how far Adolf lives. To find how much closer Jimmy lives, we just have to subtract his distance from the distance that Adolf lives from the school, and we'll have our answer. So we take y minus x, which is approximately 2.682477 minus 0.896710, and we will get that that's about 1.785767 miles. The problem says to round to the nearest hundredth, so I know my final answer would be 1.79 miles. So Jimmy lives 1.79 miles closer than Adolf does. And we've solved the problem now. And we didn't have to draw on a right triangle because we now have the law of sines. As you flip to the back, our next problem says it wants to find B. So this is what we want to find. If measure of angle B is 75 degrees, C is 9, and A is 10. So we don't know if we have a right triangle. All we have is 75 degrees. So we can't for sure use our regular trig ratios. So let's try and use law of sines. Well, when we look at this, if we're trying to find B, we have the measure of the angle opposite B. So we could do sine of 75 over B. When we try to set that equal to something, though, we don't have another angle measure to pair up with either one of these sides. So we're kind of stuck. We're not able to use law of sines in this case because we'd have a proportion that has two variables and we won't be able to solve. So let's approach this the same way we did the first one. I'm going to make a little squiggly line. Go ahead and try and draw in a right triangle that would allow you to use our regular trig ratios and solve this problem. You can pause right now if you'd like to try this on your own and then check your answer with mine. The triangle that I'm going to draw on the altitude from vertex C again. Gives us two right triangles. So I'm going to label this length x, this y, and this z. Well, as I look at this, I know that I can find both the value of y and x because I have an angle measure and a right triangle and one of the side lengths, so I can use trig ratio to solve this. So if I'm finding x is opposite of this angle and we have the hypotenuse, so I'm going to use sine. So sine of 75 degrees will be equal to x divided by 10. If I multiply both sides by 10, I get that 10 sine of 75 degrees is equal to x. I can set up another trig ratio for y. When I look at y is adjacent to 75 degrees. So adjacent over hypotenuse would be cosine. So I know that the cosine of 75 degrees is equal to y divided by x. If I y divided by 10. If I multiply both sides by 10, I get 10 cosine of 75 degrees is equal to y. Now that I know this length and this length, I can find z by using segment addition postulate. If AB is 9 and y is 10 cosine 75 degrees, then z must be equal to 9 minus y, or 9 minus 10 cosine 75 degrees. So I have x, I have y, I have z. If I know z and x, I can use the Pythagorean theorem now and find b. I know that using the Pythagorean theorem, z squared plus x squared is equal to b squared. Well, z is 9 minus 10 cosine 75. 9 minus 10 cosine 75 degrees squared plus x, 10 sine of 75 degrees squared. That will be equal to b squared. Now I'm just going to put this entire thing in my calculator, and when I do that, I get that b squared is approximately 134.412579. Again, I'm keeping all these decimals because I don't want to round until the very end. So now I take the square root of both sides, and I find that b is approximately 11.5936436. It tells me to round to the nearest hundredth, so b will be approximately 11.59. So again, I can create a right triangle and then use trig ratios and Pythagorean theorem and eventually get to what the length of b is. Now I want to develop another formula that will allow us to do this without having to draw in our right triangles. So let's go down here. We're going to develop the law of cosines. So when I do this, I'm going to draw in that altitude from C again. I now have two right triangles. I'm going to label the length of the altitude x. I'm going to label this length y again. And now over here, instead of labeling this z like I did before, I'm going to label this c minus y. So from here, I now have two right triangles. I'm going to use Pythagorean theorem to set up two equations. So we have x squared plus y squared will equal a squared. And I have that x squared plus c minus y squared is equal to b squared. Just the Pythagorean theorem that we've used before. Now if I multiply this guy out, I get x squared. Realize that c minus y squared is not c squared minus y squared, it's c minus y times c minus y. And if you use the distributive property and multiply that out, we get plus c squared minus 2cy plus y squared equals b. And what I'm going to do with both of these equations now is solve them both for x squared. So if I solve this equation for x squared, I get x squared is equal to a squared minus y squared. And if I solve this equation for x squared, I get that x squared is equal to, sorry, that was b squared minus c squared plus 2cy minus y squared. I've solved both equations for x squared, so now because x squared is equal to this and this expression, I can set those expressions equal to one another. So b squared minus c squared plus 2cy minus y squared is equal to a squared minus y squared. I'm now going to solve this equation for b squared. I do that by adding c squared to both sides, subtracting 2cy, and adding y squared. I'm going to line this up with the like terms. And then when we add this, these all add to be 0, and we'll see what we have remaining. b squared is equal to a squared plus c squared minus 2cy. Well, we have everything in terms of a, b, and c from the original triangle, but we have this y here. So I'm trying to think, well, how can I get rid of this y and replace it or substitute it with something that involves values of a, b, and c from the original triangle? Well, when I look back to this original triangle, I see that I can relate y and measure of angle b and side length a. So going back up here, I know that the cosine of b is equal to y over a. So if I multiply both sides by a, I get A cosine of B is equal to y. I will now substitute that in to our formula, and I get that B squared is equal to A squared plus C squared minus, I have 2 times C times A cosine B. I'm just going to orient these so A and C are in alphabetical order. 2AC times the cosine of B. And now we have a formula that relates the side lengths A, B, and C and one of the angle measures to one another in a triangle that's not a right triangle. This is called the law of cosines. Now I have this solved for B squared, but we could do this exact same thing and have it solved for A squared or C squared. And if we did that, we would get that A squared is equal to B squared plus C squared minus 2BC times cosine of A. And if we solve that for C squared, we get C squared is equal to A squared plus B squared minus 2AB times the cosine of C. Now when you look at this, you may think, oh my gosh, these are crazy different formulas. There's 3 formulas I need to know. Well, there's really only one. And what you need to notice is that the side length B corresponds with the angle measure B. Side length A over here corresponds with the angle measure A. Side length C corresponds with the C. And then the other two, A and C, are what are both multiplied here by the cosine. B and C, B and C. A and B, A and B. So I wrote 3 formulas just so we could see it's really the same thing, just depends on which one you choose to label A, B, and C. So these are called the law of cosine. What the law of cosine says is if triangle ABC has side lengths A, B, and C, as shown above, then this is true. So here is your law of cosine. You will not have to memorize this, but you do need to know how to use it. And students often find law of cosines a little more tricky to use than law of sines. However, there are times where we have to have law of cosines because we cannot use law of sines. So as we go back to this problem above, we're going to solve this exact same problem but using law of cosines. I'm going to show a little bit more work than you usually need to show, but I want to show all the steps. So we're solving for B. So B squared is equal to A squared plus C squared minus 2AC times the cosine of B. So if I substitute the values in that I know, I can find B. So B squared is equal to A is 10, 10 squared plus 9 squared minus 2 times 10 times 9 times the cosine of 75 degrees. So as I simplify this, I get 100 plus 81 minus 180 times the cosine of 75 degrees. As I continue solving, I can combine like terms. Notice this has a cosine of 75 degrees. I cannot combine that yet with these two. So I'm going to do 100 plus 81. I get 181 minus 180 times the cosine of 75 degrees. B squared is then approximately equal to 181 minus 46.5874. So B squared is approximately 134.4125719. And again, when I take the square root, I have that B will be approximately plus or minus 11.593643. Now, we don't need the plus or minus because B represents the length of the triangle, so we know it can't be negative. It asks us to round to the nearest hundredth, so we get approximately 11.59. Now, if you look at this, you may think this seems like just as much work as the left-hand side, but really, as soon as we substitute in, you could skip these steps and jump right to this if you enter this all in your calculator. So now, let's use law of cosines to solve triangle ABC. Now remember, when it says solve the triangle, that means it wants you to find every angle measure and every side length. Well, it gives us that A is 8 feet, so I'll substitute that in there. B is 18 feet. And C is 13 feet. But when I need to solve, I still need all these angle measures. Now, if we use Pythagorean theorem, we'd see that this is not a right triangle, so I can't use trig because a squared plus b squared would not equal c squared. So then I either have to use law of sines or cosines. Now, law of sines seems a lot easier, so when I check this, I'd first want to see if I could use law of sines. Now, when you look at this, you don't have any angle measures, so if I tried to do law of sines, I'd have two variables with one equation, and I wouldn't be able to solve. So instead, we have to use law of cosines. So when I look at this, let's first solve for A. Oh, sorry, we have A. Let's first solve for measure of angle A. So if I'm looking for measure of angle A, that means I need to use the opposite side of that, squared, equal to the rest of the formula. So we have A squared is equal to B squared plus C squared minus 2BC times cosine of angle A. And remember, that's what we're really trying to solve for, measure of angle A. So H squared is equal to 18 squared plus 13 squared minus 2 times 18 times 13 times cosine of A. Notice this time we're solving for A instead of a side length. So this is solving this equation is going to look a little different. You got to hone in on your Algebra 1 skills. Here we have 64 is equal to 324 plus 169 minus 468 times cosine of A. Now, a lot of times what students like to do is add all these up, divide by that number, and then solve. Unfortunately, we cannot do that. This negative 468 is multiplied by that cosine. So when I'm simplifying, I cannot combine that with these two. I will add these two together, though. I get 64 is equal to 493 minus 468 times cosine of A. Now I can subtract 493 from both sides. I get that this is approximately 0.91666. Repeating, so negative 468. Oh, sorry, no. This would be negative 429. I apologize. Divide by negative 468. This is when we get that number. 0.91666. Repeating is approximately cosine of A. Now, in order to solve for A, I have to do the inverse operation, which is inverse cosine. So cosine inverse of this angle. That gives us approximately 23.556 degrees. And again, we'll round to the nearest hundredth at the end. We can do the exact same thing if we want to find the measure of angle B. Okay, so B squared is equal to A squared plus C squared minus 2AC times cosine of angle B. And I substitute in what I know. 18 squared is equal to 8 squared plus 13 squared minus 2 times 8 times 13 times the cosine of B. And again, I'll solve this using the exact same steps. 324 is equal to 64 plus 169 minus 208 cosine of B. Combine the like terms that I can. 324 is equal to 233 minus 208 times the cosine of B. Subtract 233 from both sides. I get that 91 is equal to negative 208 times the cosine of angle B. Divide by negative 208, divide by negative 208, I get negative 0.4375 is equal to the cosine of B. And when I do inverse cosine, I can now find the measure of this angle. I get that measure of angle B is approximately 115.9444. So, my final answer is that I would measure of angle A is approximately 23.56 degrees. Measure of angle B is approximately 115.94 degrees. And if I remember that the sum of the measures of the interior angles of a triangle is 180, then I can find that the measure of angle C is approximately 40.50 degrees. That way I do not have to use the law of cosines again. And now we have solved for this triangle.